Thanks very much for the opportunity. I want to reflect back on the first comment that was made in a first presentation. Michael talked about the relationship of data to research to public good. And that connection is really strong. And the interesting thing from my perspective is that the connection isn't just data to research to public good. There's a direct connection as well. Now, I'm aware that I have many of my esteemed Department of Innovation colleagues here, and entering into the realm of policy is a risky thing to do. So let me say, all of the good bits are down to them, thank you, and the other bits will be my misinterpretations. So let's go forward. I want to spend a little while on the research and policy challenges, then move to the data challenges. I want to look at opportunities and then have a look at the Australian research data approach to that space. So, some policy challenges. Again, these are not research challenges. These are challenges to our country. How do we work out where to live in Australia? Many of you coming from overseas will have taken out heavy insurance to come here because you will recognise just what a dangerous place Australia is. And, you know, it's a light-hearted thing, and yet we have had just diabolical things happen. And we need to understand where we can build. What can we live near? What do we need to not be close to? Our largest living treasure in Australia is the Great Barrier Reef. How do we look after that effectively? How do we balance the many needs associated with that? Those of you who have travelled a little bit around Australia will determine that Australia's soil is fairly ordinary. Fairly ordinary to really, really ordinary is kind of the characterisation. And the challenge then is to how to use that soil. Some policy challenges for the country as a whole. What data environment is needed to understand the policy on where to build and the effects of bushfire? What is the data environment that enables our researchers to understand this greatest living treasure? What about the data environment that enables people to look at Australia's soil from many dimensions, from the satellite, from the field surveys, to the microanalysis, to the genetic analysis? Do we say to the researchers in those spaces, go off and tell us what you know, come back, we'll work some stuff out as a result of what that is happening, or do we need to build teams who work over a really rich data environment? So, the research data challenges then are the collecting and organising data on bushfire and environment in bushfire-prone environments. Collecting, integrating and making usable Great Barrier Reef data. These data won't come from single sources and they won't be subject to single disciplines. They will be across the space. So the challenges are very intense in this regard. Integrating all of these different layers of data where, I have to say, for many conversations I have, the conversation is really around, well, what we do is the kind of right way to do data, and what we're trying to do is build up approaches that enable others to join into that space. So there's, if you work in geodata, then you will be typically using some sort of georeferencing in the space. But what happens if you work at the micro layer, etc.? So there's real challenges associated with that. There are indeed educational challenges. I love this little picture. It's a picture of Jimmy Chan from University of Maryland standing next to the big beasties. And really the statement was that the researchers were being trained on too small data. And I know it's true because I was. We absolutely worked on the wrong scale. So how do you make the data available not only for research but for educational exploration as well? So here's the standard list of research data challenges. First of all, big data typically is thought about in terms of size, and that's really important. We know that it's really hard to put in place the environment that allows people to work on data at different scale. How do you in fact pull the pieces together? How do you get the compute, the store, the transmit? And not on this list, but absolutely crucially, how do you get the tools in place so that the data and the tools work together in this environment? We just heard exactly that challenge in the last talk. The next big data challenge is variety. Data types don't respect boundaries, nor do they necessarily respect ontologies. So the integration of data from completely different disciplines is an enormous challenge in this space. So how do we build the bridges that enable us to work across this variety? One that is absolutely scary to the computer scientists in the room and around the world is velocity. And indeed to anybody interested in looking at the challenges of verifiable science. How do you deal with that data that is simply streaming past? You can observe it going past, but you cannot keep it. One of the things we know about data is that there's too much of it. And things like the SKA are going to generate so much that almost none of it will ever be processed beyond that first step. So what do you watch? How do you watch it? How do you detect anomalies? How do you summarise data in that environment? And then, how do you conduct verifiable research when all you know is that the stream has happened? What do you do in those circumstances? A huge research data challenge in big data is human effort. We can't use the old mechanisms for handling research data. They just won't work. How do you use the scarce and precious resources that are us in this space? We've got the machines that are going to make life more difficult for us constantly. Every time a new supercomputer is installed, we get a harder problem. Every time a new instrument is installed, the problem gets worse. We put the instruments in place, we don't have a corresponding increase in the number of people working on the space. So thinking through hard about how do we use that effort carefully, it can't be used in filling millions of forms, fairly clearly. And then the one that's kind of the real trick in this space is human cooperation. Most researchers who have grey beards or the equivalent have grown up in a world where doing research was essentially an individual activity and in fact succeeded that way. How do you work together in this space? It's one thing to work with a fellow researcher down the corridor. What about working with Richard, with the guy who puts the software in place that makes this work? How do you work with the person who actually understands information environments, possibly even a librarian? How do you work with librarians in this space? And that's the challenge moving forward. We need to have new sorts of teams in the space. So, here's an example where the challenge has been met, in my view. A really interesting example is the Hubble telescope. Commissioned in 1990, focused increasingly on cross-disciplinary science. It required that if you got time on the Hubble telescope, you deposited your data with the Space Science Telescope Institute. And that data had to be made available to all beyond. They had a whole lot of people applying, only a certain number have got in. But the fact that the data was held at the Space Science Telescope Institute enabled people to use that data again. And the great story for the people who used it first is that they get cited again. So our bibliometric colleagues will be working hard to ensure the fame of the researchers that make their data available. Thank you. So, here are some research data opportunities and policy drivers. First of all, we need to be solving bigger problems. We can't simply fund question-driven research only, in my view. There's going to always be a fair amount of money expended on solving big problems, like the ones that I mentioned before. We also need to be able to conduct actually different sorts of research. So systems biology wasn't really possible until the data environment changed. So you're kind of building in new research areas. You can conduct more efficient research because the data can be routinely and efficiently combined and reused. So that cost associated with the data acquisition is reduced as a total cost of the research system. Then you can provide that data in a form that enables data to drive and inform policy. You can use data as a new partnership mechanism. We saw earlier Julia talking about that interconnectedness that exists in the space. How do you in fact get those connections? You can sometimes use those sorts of analyses to look for relevant partnerships. And finally, and for me really interestingly in the Australian environment, it enables institutions to define strategic intent and then support that strategic intent with data. A very simple example is James Cook University has established itself and made it very clear that they wish to be seen as the university who works on tropical research. So it makes absolute sense for them to ensure that their researchers have the best access to tropical research data in that environment. So how do you go about doing that? And for me that's really important because it says that the policy drivers in this space work at a whole range of levels, at the whole of government level, at the people who provide data infrastructure level, but equally importantly at the research institutional level. So I want to spend a little while now on the Australian approach to research data. First of all, data is an asset to be managed. Data is not a byproduct. Data is not something that simply goes away. It's crucial. Another policy is data is intended to be shared. Data isn't there for the sole purposes of the researcher who was lucky enough to get the grant. Or the data that comes off a particular instrument isn't designed for an individual. Data that comes off an instrument that's publicly funded is intended for the community. So the form of investment in research data is interesting in this regard. So there's been substantial investment in infrastructure that enables new data to be generated, the big facilities, the synchrotrons, the telescopes, the high-performance computers. We have big networks of investment in research data. Ocean observing in Australia has moved up a very substantial level. We have so much more knowledge about the ocean around Australia than was the case 5 years ago because there's been a substantial investment made in that space. And equally in Earth observation, we know more around the space than we did. So there's these investments in new data. There's equally been investments in infrastructure that enables that data to be integrated. Those same investments being made in the acquisition of data have put some of their funds aside to ensure that that data is integrated into that space. And so one can go to the Integrated Marine Observation System to access much of Australia's oceans research data. And so just flicking back to the policy settings in this space, a key element in that space has been the Australian Code for Responsible Conduct of Research, which has statements about the responsibilities for the researchers and the research institutions. And I think it's fair to say that it's been a very strong driver around changes in research institutions in this space, and probably less strong at the moment for researchers. But I think all of these things take time to apply. But it has been a really interesting thing that it's been very clear to research institutions that they have a responsibility for research data. And that responsibility is not the case around the world. Sometimes responsibility is held at the researcher level, sometimes it's held at the institution, the sub-institution level, sometimes it's at the discipline level, and sometimes the kind of approach that was taken with the Space Science Telescope Institute. But we've found that this driver has been really quite important to engage research institutions in a discussion around how to do that stuff well. Now, the next element of the investment in research data is to say that data isn't data. So in some sense, to pick up again on the point that data rots. Data isn't available and just good forever if you put it in a box. Data actually has to be enhanced in a whole number of ways. We need new tools, both generic and domain-specific, that support the use of research data. we need to make the data available through high-speed access to very large data stores. And we need to be able to process that data through high-performance computing capabilities. We've got very specific domain enhancements. So in our social sciences area, the Australian Data Archive provides curation services to ensure that the data is made available in alignment with other social science data archives around the world. There is explicit domain enhancement in the Atlas of Living Australia and the Marine Information Portal. And then as well, we're trying to build a national asset, which is the Australian Research Data Commons, a network of that data around the country, and I'll talk about that in a moment more. As well, there's been a really important change at the institutional level, in that data management and data enhancement has been pushed quite hard at institutional level, and we've seen a massive increase in the capability of our institutions in Australia to manage and manage its research data. And then there's researcher training to ensure that they are able to work with their research data assets more effectively. We've spent some effort on that, but arguably could spend more in that space. And then a third element to the Australian approach to research data, which is about partnerships. I bang on about partnerships quite a lot because I think it's really important. It has to be a partnership between players who aren't naturally aligned. So the researchers, their institutions, now they're not naturally aligned, but they need to be in this context. The data providing instruments, the data providing institutions, the locally research data providers, the national providers, the disciplinary initiatives, the international consortia. They've actually all got quite distinct roles in this space, and arguably you don't want to have to provide a roadmap to researchers that tell them this is how you engage. It has to be, roughly speaking, transparent, but it has to be the case that any point of access works. So research labs are important about the planning and using data. We've got the research institutions in data management, disciplines, particularly important for ensuring specific collections emerge, e-research providers providing tools that don't rot, the data holders, the national service providers and international consortia in this space as well. ANZ was created by the Australian Government to enable researchers to use research data more often, to enable a coherent institutional approach so we didn't have too many different approaches around the country, to provide a forum for working on research data. Really importantly, to work on improving the value of research data, and I'll get to that again in a moment, and then creating a populated research data commons, the Australian Research Data Commons, and, oh gosh, building partnerships. So, how do you make data more valuable? Well, one is it's got to be able to be used later. So what do you need to know about the data now in order to use it again? It has to be able to be used by more researchers within discipline and across discipline. Really importantly, it has to be able to be integrated to enable you to answer new questions and to explore new data spaces. So we know that in this new world, some of what we do is answering questions and some of what we do is exploration. We need to support both. So to do that, we argue that data needs to be managed, it needs to be connected, discovered and then reused. It has to move out of the research lab. So our approach to doing that is to work with institutional partners in particular to ensure that data moves from a whole lot of data assets to structured collections that move from unmanaged to managed, discovered to connected, invisible to findable, and single use to reusable. What we're trying to do is derive up the value of Australia's research data assets. So then, Australian researchers can publish, discover, access and use research data. So, the Australian Research Data Commons then is, we probably try and use the Amazon analogy rather than the eBay analogy here, in that we want to publicise research data so that it is known about and available for other researchers. It's that collection of data that are described. as well, the relationships between the data and the researchers and the problems and the instruments and the institutions, and indeed some of the outcomes that Julie was talking about before. How do you bring all of those connections together to ensure that you've got that space? And then the infrastructure that enables the population and exploitation of the commons. So what we want to move from is a world where data lives in a whole bunch of different places where there's been specific discipline interventions, we should exploit that, to start building connections. We want to connect the data that exists in a research lab to a local managed store. We want to provide the institution with the ability to know about its data through a metadata store. We want to connect those metadata stores to an Australian Research Data Commons with a whole lot of collections descriptions and a portal that makes available the knowledge of Australia's research data assets in that context. And then you move to something that moves beyond a whole lot of individual data to a data commons. So, the result, automated metadata gathering, problem formulation. Data collection discovery is possible when you've got descriptions at a wider level. You can integrate and you can investigate. And so the data's value is enhanced by preserving rich context. We believe that's typically done early on. So ANZ has been running for more than 3 years now. We've been working in partnership with institutions. About 150 projects, 120 partnerships with institutions to establish these data connections, these data bridges. We have an operational research data commons. We've got over 35 collections with all disciplines except philosophy, and we are assured the philosophy data is coming soon. Really importantly, from an Australian perspective, the institution's very actively engaged in the space. And the funny thing about what I've been talking about is an Australian context, but research doesn't happen in Australia just. And the partnerships won't be happening in Australia just. So ANZ has been very actively engaged in international engagement. So here's how the space is playing out at the moment. We have many tools being created in all of these environments. They look like pieces of infrastructure, they look like pipes, they clearly are infrastructure for the purposes of the definition. But really importantly, they can also be seen as bridges. And I want to get to that in just a moment. So, why do you have partnerships? You have partnerships to build bridges. Thinking back to wars, one of the first things that people do is blow up bridges. They break partnerships. The power of a partnership is often expressed through a bridge. And so we've been working closely with colleagues in the EU, US and Canada on developing a mechanism that establishes more and more research data bridges. It's been done in particular in the context of something called the Data Web Forum, which is an initiative that has been driven out of the NSF, but equally out of strong European initiatives around data access and infrastructure, technical workforce. But the aim is then to try to put in place a mechanism that exploits all of the things that are already happening and enables a mechanism to be put in place for what happens next. The aim is to use an IETF-like approach. That is, rough consensus and running code. But running code isn't enough in our space. If you haven't, in fact, transferred data, if you haven't enabled data to be interchanged, you don't get the tick of approval. But the idea is, as soon as data is interchanged, good things have happened. So here are the data bridges that we can imagine being in existence. Don't you think these data bridges look very pretty? Thank you. So we heard earlier from Ray about the system of world data centres being established around the world. Within Australia, there's a whole bunch of national research data centres being established through the Research Data Storage Initiative. We have a whole bunch of institutions who have research data storage capabilities. At Monash, there's something called LARDS. But there is no one answer to where data is going to lie. It's going to lie sometimes within a disciplinary space, sometimes across the space. But researchers should not need, in fact, to work hard at getting data into a particular location, finding it in a particular location. There needs to be a mechanism that enables that to work. It needs to be working across disciplines. It absolutely needs to work across countries, because researchers will never respect a country boundary. They will need to work in data spaces across that space. And really interestingly, it needs to work across time. That is, data that is created today has to be available for new uses into the future. In conclusion, this big data generates big challenges and indeed big opportunities. The Australian approach is to ensure rich data is captured, enhanced and made available for new problems, and especially big ones. This requires new partnerships and new bridges. Why? Well, I hesitate to say it. It's not about the data. It's about the possums. So, possums don't sweat. Our New Zealand colleagues don't care. Just rest in peace for a moment. So possums don't sweat, and possums that are located in the northern climes of our national parks are at the uppermost end of their territorial area. They can't go higher. If it gets too hot, they'll die. So the refugia studies that are conducted at James Cook University on where possums can live need to be integrated with models of climate adaptation that explain what the possible futures are. If the rain drops and the temperature varies, what happens to the possums? So we need rich data in rich context for new problems. The models of the data, outputs data, all of it needs lots of context and lots of access methods, and the result is you can actually put in place a policy around a national park system that is resilient to climate modification. And thus we have the final dot point: data improves research, improves quality of life. Thank you, Michael.